Hi, it's Gadget UK here again. Consider this just a bonus video because this is not something I normally cover on my channel, but I'm having to branch out. Anything I fix around the house and stuff, I'm just going to film it anyway, so just consider it an extra bonus really. These types of videos aren't going to be my main focus, so I will still be doing my normal, regular content, so this is just an extra thing. You can see it's pretty loose. I've had this problem before, fixed these glasses a number of times for my wife. You can see the nuts come off, they just get loose. So I might find some way of securing the nuts, but she's lost the screw actually. Sorry, the screw's there. You can see the screw still through there, but she's lost the nut. So I ordered some screws and nuts, a full set here, look, designed for fixing glasses like this. So hopefully these are going to fit. I mean, they're all different lengths. I'm guessing that they might use a standard size screw. I'm hoping these nuts here will fit. So let's just see if that's the right size. Oh god, this is going to be super fiddly. You can get like a little jeweler's screwdriver hex type fitting that will go around that will assist you getting this on, but yeah, I'm just going to have to try and do this by hand. Ugh. Talk about fiddly. Ugh. Ugh. I seriously don't know how Vince. I was going to say, I seriously don't know how Vince does his watch repairs, because these are similarly small, maybe even smaller, and it's just near impossible. I just want to try and hold that there. If I can get it to sit on the top of it, I can use the screw from the other side, I think. Oh, goodness me. The other thing I could do here is just replace the screw as well if it doesn't quite fit, because obviously I've got a full set of the screws and the nuts here. Oh, God's sake. The other thing you need for something like this is a jeweler's screwdriver set. You can see you get some pretty small flat blades and crossheads and things as well. So yeah, again, only £3 or £4 for a kit like this. So there were two size nuts actually, 1.2s, that's what I was trying to fit on there, that's why I couldn't do it. It's actually 1.4, the screw that's already in it. But you know, you've got all the different lengths of those different thicknesses of, you know, replacements here as well. So yeah, a kit like that, you can see I've got that back on. I just need to tighten it up now, but yeah, a kit like that, just set you back a few pounds, £2 or £3. It's always worth having one, because whenever your glasses, any kind of glasses break, you know, you lose the screw or the nut, you can fix them yourself. I mean, this wasn't a particularly expensive pair of glasses, but it's sentiment and all the rest of it. And as you can see, that's secured on there nicely. There might be other tips and tricks to help secure that. Maybe get a bit of that lock nut stuff. You can get, it's like a little glue that sets to like a quite hard plastic. You could just put a drip of it there and it will secure the nut. Washers, another thing as well. I'm not sure this kit comes with any washers, so you could stick a washer under there before you stick the nuts on. Anyway, I'll tighten up the other parts of this now, but yeah, I'll just push the ear bits back on because those are coming off a little bit. So we're all done now. You can see the fittings here super tight. I've tightened the screws there as well just to make those a little bit tighter, and also tightened up the ones there as well, so good as new. So I cleaned up with a bit of Windoline here, so they're looking good as new. All the screws have been super tightened up there, the nuts. The other thing that's worth doing is you can get these as replacements. If you ever lose these from glasses, you can get them from eBay for, I don't know, 50p or something. They're pretty cheap. But you can just squeeze the ends there, the little metal bits, because you know it's like it's held in by the you know, you can see the little indented bit. There's one on each side of that metal piece there. So just a gentle squeeze like this every now and again, you know, in terms of maintenance, can help so that you don't lose the nose bridge bits. You can see it's the make of this one is a Biron SX1. So you know, you put two batteries in there. I've changed those as a brand new batteries, measured on the meter. And I guess it's worth showing you this as well. You could buy a digital multimeter, super cheap, probably like £7.99 or something off eBay, and it'll have something like this where you'll have a dial where you can choose, you know, volts AC, the wiggly line, volts DC, you know, that straight line above three little dots, you know, dashed lines there, that's DC, resistance, diode test, etc. But you can get something like that for £7.99ish. You know, you'll get them dirt cheap, and you just put one probe, you know, the negative probe on the negative side and the positive on the positive. It doesn't even matter if you get them the wrong way around, because it'll just show you a negative voltage or so. can see it's got the negative indicator up there. But yeah, those are flat. So yeah, that is the first thing I've done. Swap those batteries out. They should be 1.5 volts and they're measuring about 1.2 something. The button for the doorbell, let's just try it now. Not working. Bear in mind this has got brand new batteries in it. Not working. So the next obvious thing is to check the button cell here. You know, just pull it out. So you've got one side there, and you can see there's a ring, like a plastic ring there that isolates it from, you know, the other side. So again, cheap £7.99 multimeter. Well, this one wasn't £7.99, but you know what I mean. You can get one that price range. And if we measure that, hang on, put it on volts, not diode test. 2.7. So this should be just over 3 volts. So yeah, that's a bit low. I don't think that's the actual problem though. So we'll change that battery in a minute. The next thing I need to do is get the screw here out of this, just holding this little circuit board into the doorbell bit here, you know, the button. So the bit when you push this here, obviously it's pushing that little switch there. This has been replaced, I think, once already. The board, as you can see, you know, there's very little on it, little resistors and capacitors and transistors. So I mean, you could inspect something like this super close to see if you could see any cracks on the solder points, you know, the grey silverish connections there. And if there were, you could just, you know, heat them up with a bit of fresh solder and flux. You need to be careful because they're so small, you could easily join something together there if you're not careful. But yeah, my instincts are telling me it's going to be this switch again, because the last time it was replaced was, I don't know, several years ago. Doorbells, you know, these switches like this, they're outside as well, it's outside your house, so you know it will be affected by the elements. So the other thing with multimeters, if you put it on a you know, continuity test, diode test, there'd be something with a little audible symbol like that, something where you think, oh, that makes it's a sound wave, you know, it's a buzzing noise, and when you put the probes together you get a beep. So that's just testing that things are connected to each other. So this switch, it's got 4 contacts on it, you know, it's 2, one there, one there, one there, one there. 4 contacts in total, but the 2 are switched. So if I press the button, you see we've got a resistance there, but it's not a short look. It should be beeping. Yeah, I'm going to swap it out, I think. 9 times out of 10, that's what it'll be. It'll be these little tactile, they call it a tactile switch. It's something like 6mm. I think it is 6mm by 6mm square. And you can see it's quite a low profile on the top there. So I'm hoping I've got something similar. Yeah, these ones might just do the job, I think. So if we have a look at one of these, yeah, can you see that? That's going to be a perfect replacement. So we just need to just, you know, heat and pull this off and put a new one on. So it could be quite challenging to remove this actually, because you've got to heat the top side. You know, on many circuit boards you could, you know, heat the underside here and just use a solder sucker or something to remove the solder. But we've got 4 contacts and they're all on the top side. So it's a question of how do you get the solder off that easily. You could try and heat 2 pins at once, but you see this is where you need more hands than you've got, because you need to somehow pull the switch as you you know, heat the points here. You could try and get something underneath it to lever it as you solder. I might just try and do that to see if there's any way I can kind of lever it off. So if you heat both at the same time there like that, you can see it's coming up, look. Yeah, so we're off on one side pretty much. That's probably the easiest way in this particular case. It's going to vary depending on you know, what kind of doorbell you've got. They're not all going to be the same. So I think we'll just do this corner here and see if we can just prise it up on that corner. Yeah, we can, look. Oh, yeah, it's still sort of attached, can you see that? There's still solder attaching it there, but if we now try the last contact down here, see if we can lift that up. There you go, that's almost off. Heat the other one. Yeah, there we go. There's a big lump of solder or something there. What's that? I hope it's not a component. Maybe it's just a bit of solder. Yeah, can you see that? A big lump of solder there. So I'm just going to heat that and just try and get that out of the way. Yeah, there we go. Yeah, so it was in that position, wasn't it? Wasn't it in that one? Yeah. So if we get the new one on there, let's see if we can push it into place. So you might want to just straighten out the legs. Sometimes these have got like a little crimp in. These have. It kind of helps design, make them snap fit actually, so they hold themselves into a PCB. But I'd rather they were nice and straight, so that when we stick it in here, it just goes in a little easier. Of course, you could clean up the solder points. You know, if you've still got lots of crusty solder there, that means the hole's not fully unblocked. So the final thing now is to secure those 4 corners. I'll start with this one up here, and We can all straighten it in a minute if it looks a bit wonky. It's difficult to do it from this distance, I can't see what I'm doing. Let's just see if we can hold that, like that, so that I can get the iron in that angle there. Why is it not joining? I'm having a hard time getting that to join on that corner actually. Let's try this side. Yeah, so let's try this one down here. This one might be a bit easier, he says, and it's not, is it? It's not wanting to join. There you go, it's joining now. If your PCB's a bit weathered, you might want to clean it up with some IPA, you know, alcohol on a cotton bud first. But you can see we've got one connection there. There we go. And then we'll do the awkward one that wasn't soldered before. Yep, there we go. That's three done. We'll just finish off on this corner here. Okay. You do want to be using solder containing flux, and I always use leaded solder. Leaded solder tends to be better, but as you can see, we've got our button on, we've got our four corners. So let's stick the battery in. Let's see if that's any better. Bear in mind I will change this battery because it's an awful battery. Now with this doorbell, I think you have to reset it because they kind of sync. You've got to press the button on this and then the button on the doorbell, and then they kind of sync up. So I've pressed that. Yeah, so it rings, and then I press this button. Still not working. Now that might just be as a consequence we have got a low battery, but the button did need replacing. So let's go and get a new button at Cell as well. So a brand new battery here. CR2032 is the most common one, but you know, you can inspect the battery. They'll have a marking on normal. It tells you the code, and you could, if you don't know what the battery is, like look for those codes on there. Typically be CR something, and just search for it on eBay. You'll find a battery like less than £1 often. If you know, get a decent one like this one or the Duracell one, you'll pay a bit more. I mean, you can see it on there. Can you see if it's got the light right? You can see it says Panasonic CR2032, 3 volts. Yeah, that's the most common one. And we've got the late Alison Shallis to thank for this. This is yet another video where one of Alison's components is featured. She had a load of these batteries. They do expire. The expiry date on these is this year. I've still got quite a few of them left, but they'll be okay. They don't go off super quick. So let's press the button now. Still not working. So let's try and reset it again. Press the button, it will ring. Then we press this button. Still not working. That's super interesting. Oh, it is. There you go. I don't know why. I've had this problem with this doorbell before where it doesn't always sync straight away. There you go. See, it's working. Give it one more try. Yeah, that's working. Now, the final thing I will do here, I don't know whether you can see, there's a super small inductor there. It leads to this trace. This is the aerial. This is where the wireless signal comes out of. Quite why it's cut there, I don't know. I suspect that's something to do with frequency. It might be a case of if this ran all the way to the end there, it's on a different frequency than what it is when it's cut off here. You know, they've cut that out of manufacture. So I don't know. I'm just guessing. It might not be. Yeah, the solder points don't look that great. So I'm just going to get a tiny little bit of solder on each side there and reflow that. Everything else about it looks okay. I don't see you know, any other bad solder points. It's just this little inductor here, and it's super important that's got a good join because that's where the wireless signal comes out of. So if we just add a bit of solder and flux and just touch into it, there we go, and we'll do the same on this side. I think that'll do it. Someone's at the door. They can't ring the doorbell. I will clean up with IPA and a cotton bud in a minute, just give the board a little bit of a clean, maybe even get the toothbrush onto it. But if we just give it one more try, yeah, that's working fine. So we'll just give it a clean with some IPA and a toothbrush. You could just use a cotton swab, you know, cotton bud. But if we just give it a bit of a brush like this, it's just going to get any bits of flux off and dirt and corrosion and stuff like that. And then we'll just give it one final test and I'll go and stick it back out there. These things do get generally quite weathered, you know, moisture gets in there, you might find some green connections and things like that. you know, the things I've done in this video, the switch and the battery and, you know, just soldering that one point, you might not need to do. You might just see a little bit of corrosion in there. You might find after cleaning it like this, it works again. Or you might just need to add a little bit of solder where it looks like it's required, but yeah, that should do. There we go, working perfectly. And before I forget, these tactile switches here, 6mm by 6mm, they are so common. Many household products contain these. These are used in Xbox 360 controllers, in Xbox One controllers, maybe some of the PlayStation controllers, hubs. You know, if you've got like a home hub, BT home hub and stuff, you'll have little buttons on it. Underneath on the circuit board, you'll have these little tactile switches. They vary. The dimensions here of 6 by 6mm, that's the common bit. If you search on eBay for tactile switch 6mm by 6mm, you'll find loads of these. The only thing that varies between them generally is the height of the button. Can you see that? That's like 1mm. So in its description, it might say 6 by 6 by 1. Some of them are, you know, 2mm or 4mm or 6mm. You can have quite a long piece of plastic on the notch there. So yeah, that's the only thing you need to bear in mind when you're looking for a 6mm by 6mm tactile switch like that. So the next thing I'm doing here is just servicing the wall heater here. It's an electric fire. You can see the two brackets here that hold it at the top. There were two, see where they are, hang on. There's a raw plug, you can see just down there, and those were the underneath brackets. So I unscrewed those, been able to lift the heater off the wall, off those two hinges at the top. The next thing I'm doing is just vacuum this wall down here, and then we'll get the heater apart. There we go, the wall is looking a lot better. The next thing to do is vacuum the outside of this, because as you can see, where it mounted the wall, again, it's covered in fluff and dust, mostly spider webs and stuff. So the next thing I need to do is get inside this to get all the dust and fluff from out the inside, actually, because it's got to be all over the inside and the elements and stuff. You can see the bit here, it's got a pin in the middle, can you see that? It's security torque, so that is the bit I need, I think. Yeah, there we go, that's going to make a good grip. And because this metal piece here is overlapping that one, I suspect that this bottom side is the side that comes off easily to gain access to the inside. Oh, drop that inside, I didn't want to do that. So we'll undo that screw there as well, and it's going to be two on the other side, and that should allow me to lift this panel off, I think, and inspect the inside of it. So that was a nightmare to disassemble, if I'm honest. You can see which half came off. I undid the screws that I showed you, and then there was one at the corner, the top corner, you can't quite see here, the top corner of each part here. And I did those, but the point here, I'll show you the plastic in a minute, it's kind of gone brittle. Can you see here? The mount, the plastic has gone like super brittle, probably because this has got super hot, and it's just broken. It's not really a problem because it's secured with all the other screws and clips and things as well, but that's what made it very difficult to get into. Anyway, the main thing is we can inspect the element here. Obviously, it goes without saying, you wouldn't want this plugged in while you're doing this. You could kill yourself on it, certainly. So, you know, there's going to be bits of dust and fluff on here. There is over there. And obviously here, you can see there's bits of fluff, dust, spiderwebs all over the stuff around here. So, you know, this is where the element is connected. This is the element. You could inspect this to make sure you've not got any breaks in that. And this tilt switch here, can you see this? You get dust and fluff around there, and that can mess things up. So I'll get a tiny, tiny, tiny drip of contact cleaner into that bimetallic switch there, because if that gets anything, any contaminant in it, and you can try blowing it with compressed air, but if that gets any contaminant in it, it's not going to work. And the other thing is this tilt switch here, you know, so that this stays level. If it's sloped to the side like that, it will switch the thing off and on, you know, it won't enable the power in case it falls off the wall. That's the whole idea behind this. I'm not sure the best place to get contact cleaner in there, to be honest. It's kind of like a sealed unit. Finally here, just wiping the top of it, you can see, look at the side over here, it's filthy. So here we are months later, I just noticed that this has been getting looser and looser, can you see? It's just like disintegrating. There's a piece of plastic here broke off, it's split here, yeah, look, it's hanging off that. So I'm going to get some super glue in there, maybe some baking soda or something. I'm obviously going to have to bend that away there to get the super glue to go right in. I'm using quite a lot there, I honestly don't care. Well, way too much, I do care. Let's just get something to mop that up. Yeah, I didn't expect it to go right down there like that. So the other thing I'm going to do is once this has, which way is it now? Yeah, once this is set, oh god, I broke it off. Yeah, what I was going to say is once I've got that to set there, I'm going to stick a cable tie around it to hold it. Oh my god, it's just crumbling to pieces, this. The whole thing is just crumbling. How has it got so bad? I'm trying to work out how that goes back on now. Right, so get a little bit more, a lot more super glue there now. And this goes like that. Oh, so hard to do. Yeah, like that there. And just sort of, massage it into position somehow. Oh god, this is a blooming nightmare. Which way around's that go now? Yeah, it goes like that, doesn't it? But then I've got to squeeze it down there. Right, that's it. So I've got super glue. I'm going to sprinkle some baking powder over it. It's not the easiest thing to do this, but yeah, just sprinkle some of that like that there. Just pour the excess out. I can perhaps just stick a little bit more of that in there then. I think what happens is it works as an accelerant, but also it's as a filler. So it like speeds up the drying, and it fills in the little gaps, and there were some gaps there. Nonetheless. Yeah, it's gone brittle, this. It's really weird. There's little bits of it just hanging off. I just hope that there's enough with the bit that I've glued back on and this to maybe get it to work. I don't even know where that bit went now. I don't understand where all the other bits of this have gone. And if anything, that's warped. It's like it should be the other way around. Oh, God. So aside from 3D printing something, you know, asking someone to 3D print something, you can see I've pulled that out of the actual fire itself, and this little band is their support. So we've got obviously huge gaps here. You know, the bits have just crumbled, and I've got no chance of gluing them back on because they're so small, the little bits. It's not aligned straight there, is it? But anyway, if we just push this in, this is why I took this out of the fire, because it allows us to push that in there. You can see that's going to fit, and it's going to be okay, but it will break. So I think what I'm going to do is get a piece of heat shrink tubing and put it so that it goes over this here. Yeah, it's going to support it all the way around, but right down to the very bottom there, and then just heat it up and shrink it. Yeah, I think I might need to go to the next size up, because I think how is that going to go over? No, it's just, oh yeah, it is, look, that's going to go over, look. It's tight already, look. But if we just slide it right down, so then we'll be able to pull this thing out here. But we're just going to now shrink that just a touch over 100 degrees here. And I'm just going to just shrink this all the way around. And hopefully that might just secure this. Give it a bit more life, I don't know. The alternative is I might need to send this to somebody with a 3D printer and see if they can make me a replacement part. It really annoys me though the way these things are designed. You know, it's like the least amount of plastic, isn't it? Just designed to fail, really. It's amazing it's lasted so long. But this is always the way these fail. Printers used to be the same. You used to have a little knob on the side for feeding the paper through, and they all used to break this way. You know, that tiny little, you know, semicircle part that captures the plunger that goes through the centre. And of course they just break. They just break. Right, that's pretty well shrunk on there. I'm tempted to go and try that now. Of course, there are other things I could do at this stage. Now we've got like a mould around it. I could remove the centrepiece and, I don't know, fill it with something and then put the centrepiece back in to fix it in there permanently. You know what's going to happen next? It's going to break off at the bottom where it joins onto the knob. Anyway, that is as shrunk as that's going to get. So let's just try pulling that out. Yeah, you can sort of see what I mean. I could literally pack something inside these little gaps here. I'm not sure what. Let's just see what that's like for strength now. Is that going to break? Yeah, I can feel it's wobbling a little bit. It really would be better to try and pack something down here, I think. The bottom bit, I'm not too concerned about. It's got a relatively good grip. I mean, I could squeeze epoxy down there, that's one thing I could do. Anyway, I'm just going to go and just plug it in and try it. So that does work, but it suddenly dawned on me, these little bits I've got here, I could actually wedge these in here, couldn't I? If I wanted to strengthen the bottom part there, so the bottom flat part does not break, I could, in theory, wedge them in. I might need to file them down a bit, I don't know. If I can just get them at the right angle, it's a bit like Tetris this. It may well just support the bottom piece. Oh, I had it then. Yeah, look at that. That's gone in perfectly. It's not where it came from. And of course it's that top bit there we've got to worry about. But you know what? That's kind of pressed up. It should be alright. I think the flat bit here is the bit that's going to get more stress. I could be wrong. Yeah, file a bit of that bit there. I can wedge that in there as well. Yeah, that could do with a little bit of super glue there. So I'll stick some on that and slide that in. Let's just squeeze that in there like that. Just push that in a little bit. See if I can push it down. It's wedged. Yeah, I might just chop the top off that actually. It's not going to go in any lower than that. Let's just trim a bit more off. Yeah, there we go. So yeah, crazy, but all we've done is just pack out the underside here on these edge bits, because those are the bits that are going to take the stress. Yeah, so there's a little bit of the material there, the plastic on the underside. That might just do the job. The big problem with this is we lost a bit of the semicircle here. You can see it's this bit here, but I think that might be alright, because it's kind of right up against the band. Yeah, nothing to lose, have we? Can't be any worse, really. But, as I say, I tested it a minute ago before we did that, and it worked fine. I rotated it all the way around 3 or 4 times, and it went click, 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 without any issue. Nothing broke off. And I think it's because this obviously is supporting the whole thing. That's not something that would have ever occurred to me. I would have never thought to use heat shrink like that. Normally I would get a cable tie, so I think I may have shown earlier, but that wouldn't fit, because this bit here goes inside the gap there. Well, the heat shrink is not too wide there to restrict it going in, so that's worked out quite well. Right, we're on wobble cam now, and as you'll see, it works. It's not too stiff, that, so I think that should be okay as long as I'm careful with it. And as you saw from the LED there, it does actually work now as well. So it was that little bimetallic switch, I think, or the tilt switch that was the problem. So something else house related here, just a deviation to the other things we've been looking at. You can see these bulbs have been driving me nuts for a while. Yeah, they go yellowed on the plastic there, and you get a dark patch there, but they just suddenly start flickering a little bit, and then suddenly it just goes off, and you think, okay, it's failed, you know, swap it out. But I've swapped these quite a few times, and they always go the same way, but just for the first time I thought, let's smell one, so I sniffed it, and I could smell a cap electrolyte. So I thought, I bet it's capacitors in these, and lo and behold, can you see that? See how the bungs come out the top there? And if I test that on the ESR meter, now obviously I've destroyed this going inside it, but there's a lesson to be learnt here for me with this one. So the next one of these, I'll have a better go at getting inside it without destroying it. If you just look at that, 17.5 ohms on its ESR there. 2.53 microfarad. I'm not sure what rating it is, let's just have a look. Yeah, 2.8 microfarad, so its microfarad rating is about right, but that 17.5 ohms is turned into a resistor, which will mean that this will not work. So that's the issue, and I cut it off. Can you see these two legs? And I cut it off. Can you see these two legs here? That's where it was, actually. There was sleeving over each one. But obviously, to get inside this, I had to, first of all, remove the cap from here, and then I pulled it out. The wires were dead taut, and you can see they've come out. So I thought, okay, clearly that's not the best way in. And then I've cut this here, and eventually it's come off. But as you can see, looking around here, you can see you've got a clip, 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 clip. And if you look on the inside of here, you've got the same thing. So actually with some sort of spudger you might be able to get under there and clip that off like that, but then the wires up here are going to be pretty tight. At that point what you might need to do is try and release the board via these little clips here. to give you a little bit of distance. But you've got to be very careful, obviously. You know, if you fix something like this yourself and put it into operation, you might burn your house down if you don't know what you're doing. So just take this as educational entertainment value. But yeah, the next time I'm going to have a go at trying to replace that cap myself, I think. You know, there's very little room here with these contacts that go to the tube. You know, it's like wire wrapped around a pin. So I don't think there's much you can do. If you could sort of get it open like that, you might be able to snip the cap off, and then you might be able to solder a new one in there. But anyway, yeah, it is the cap that most of the time causes the short life of these. And when I say short life, it's actually been in use for about 2 years, this actually, so it's not that short of a life. But if you swapped the cap out, I bet you get another 2 years out of it. And we've got yet another energy saving bulb here. It's interesting how this one's assembled. It looks like the top part is glued on there. Look, again, you can't get into it, I don't think. You can see it coming apart there a little bit. Can you see on the seams? But yeah, it's crimped there. But I just want to, if I can, somehow get inside this. I'm guessing it's going to be capacitor again. Same problem with it. Flickers off and on, like it's not coming on. And I think the LEDs and things inside there are alright. I think it's the capacitor again on the power supply. So you've seen this all before, like 2 minutes ago. But the thing is here, the point I'm trying to make is, this is all about green, isn't it? The environment, helping the environment. Why the hell are they designing light bulbs with the cheapest, crappiest capacitors in? Yeah, because, alright, yeah, save electricity, but what about manufacturing? What about all the manufacturing that goes into this, and the shipping, and the, all that sort of stuff? Why not put a good capacitor in it that lasts 10 times longer and charge us, a pound or something more? Because it's not about green, is it? It's about making money. It's about designing things as cheap as possible with the guise of it being a green product, when really it isn't green. There's nothing green about it. It's just what they're being forced to sell, because they can't sell normal bulbs anymore. But again, price, let's make it as cheap as possible. Cheap is not what we want in society anymore. Not for green, not for the environment. Cheap, it does not go with green. They don't go hand in hand, do they? They can do with the efficient design. So you can see, it's the same problem again. I'm going to have to pull it off, look. Look, there's our capacitor. Is it a polymer? I don't know. You could actually maybe service these ones, because you can see there actually I'm able to prise the top off, look. So there's our LEDs, and again, an LED can fail, you could replace it. But obviously the purpose here is to try and get to that capacitor without pulling the capacitor off. I've got no... I don't want to put this back into service, I just wouldn't do it. But I am curious as to the cause of the problem here. It's like celastic or something around there, look. Which I guess is to be expected to hold the board. Let's just try and peel some of that off. There's a lot of it there. And of course I don't want to damage my tool here. Let's get something a bit more aggressive on there, like this. And prise it out, look. Yeah, there we go. The interesting thing is that capacitor's socketed, look, I think. Goes through a thing there, look. Does it? What is that? Yeah, it's socketed, but it's one of those capture ones. You push it in and then it's hard to get out. Yeah, I'm having trouble pulling that out, but I can push it through further. That is really interesting. I've never seen that before. Anyway, let's just trim that off. I'm just curious to measure that now. It's got a purple thing around there. Yeah, you may think that's a polymer or something from the colour of it, and you know what, it could be. Now, polymers will last a long time. Anyway, let's just see what it measures on here. Yeah, 10 microfarad. Look at that, 3.6 ohms. That's the problem. It has turned into a resistor. Yeah, interesting, those connection things. Because you can see what I mean now. Look, you could literally pull that through there. And that through there. And these are serviceable. These are serviceable. Well, in a sort of sense. You saw what happened. I pulled this off here. Had I not completely detached the wires there, just hold it at the side, I could have got some tweezers there in to get the cap. Mind you, you've got to cut it off, haven't you? That's the problem. You'd have to desolder. And how do you desolder? Well, you could desolder the thing from here, and that would free the cap up, wouldn't it? And of course, there's nothing to stop me reassembling this, actually, now I think about it. You know, here, obviously a bit fiddly to solder the centre point on there, but I could literally, you know, solder all these things back on, you know, longer wires, just long enough there to solder them, fit them back in, get a new capacitor on, and then stick this back on here, you know. But then what happens if your house burns down? This is the thing. But you look at that, yeah, once that's been off and on, you could in theory reuse that. Your insurance may not pay out if your house burns down though, so don't repeat anything you've seen in this video. And whilst that capacitor has definitely turned into a resistor, I'm sure that's part of the problem. I don't think it's the entire problem. Can you see here? Look at that little dot there, black dot. Maybe that's failed. I mean, I can test that, can't I? It's just an LED. So if we bring the multimeter in, you know, and this is the thing with these LED bulbs, you can actually replace the LEDs. If you've got another one of these, you keep this as spares, say, and then one of your other ones fails. I mean, it's all crazy stuff, this, because they don't cost massive amount anyway. It's all crazy to a degree, this anyway, because they don't cost massive amounts, these anyway. Let's just see, is that open? Yeah, that one's open, I think. I'm not sure why I can't read any of these. It could be I'm not making a connection there. It could be that they're a much higher forward switching voltage than I'm thinking. So the next thing I'm going to look at here, I've been meaning to look at for ages. It's been sat around for a few years, this. It's the headset from my Xbox One. You can see the foam, like on all headsets like this, just disintegrates. It's kind of biodegradable. I've got some caps here. You can see it's going to be very tight, but that's what I wanted, something that's going to fit really snug around that. Now the difficulty here is, you can see the underside of it is under there, so you have to unscrew this, but then how do you get the screws back in? This is the thing, so we might have to poke some holes in this or something to get the screws in. I'm not honestly sure how that was assembled at the factory. So I'm using the same Torx screwdriver here that you use to get inside an Xbox One controller actually. Now the screws are a little bit corroded, so you might have to use like a thin flat blade on one or two of these if this doesn't grip. You can hear it slipping a bit there as I'm doing that. Yeah, that's one out. Yeah, it's slipping a little bit on this one, and it's slipping a lot. Let's try the next one up. On the other one, so I'm using a flat blade here. You can see that's coming out, that's one out. But this one here is so corroded that the Torx bit, in fact that's not gripping either, I don't think. Let's try and go up a size. Yeah, that's working. So I saw 3 screws out, so the cover should come off. Yeah, it's really weird how this is assembled, isn't it? Maybe you can just fit this on from the outside, but because it's, yeah, look, because it's disintegrated, I've had to pull it to pieces like this, so yeah, this is going to be too small, look, because if you look at the length of that ring there, yeah, that's going to be way too small. The benefit of taking that off like that though is we can, you know, just get right in here now and stuff. And clean out anything that might be inside there. So I may as well just screw that back together. Now I know there's no reason to actually take those screws out, but before we do that, I'm just going to clean the cavity with a cotton bud. Yeah, because the heads of these screws are worn as well, I'll show you a tip. I mean, for something like this, it's not worth it really. It's £1 or £2, the value of this, you know. It'd be easier just to buy a replacement headset. But this is the headset that came with my Xbox One, and I prefer to just try and keep the original stuff that came with it working, even if it is a bit tatty or not very good quality. Anyway, that's the holes cleaned out. So with the screws, because there was just the lightest bit of corrosion on the surface, I'm just going to use the wire brush a little bit. There you go, it's looking clean. And as you can see, that fits actually. I'm surprised. I just stretched it over, and it's snugly gripped all the way around. So that will do the job. That was a 45mm one. It's probably, I don't know, 50p each. Not very expensive at all. Got a few bits of dust on that look, but yeah, that'll do the job. So the next thing here is one of these Glade Air Fresheners. Now I have cleaned this before, leaking batteries. Let's just try it. Oh, it's working just now. It wasn't a second ago. show you anyway, because literally I tried this a minute ago, I moved the batteries absolutely everywhere and it wasn't working. So you can see the battery contact there looks nice and clean. That one, however, looks a little bit black. So we'll just go at it with the wire brush initially. And of course these can disintegrate if the corrosion is too bad. Of course you could just unscrew the 4 screws here to get inside it to, you know, pull this contact out to work on it, or to replace the spring contacts, but in general it's just the surface bit here, so a little bit of work with a wire brush like this will often solve the problem. And obviously treat it with vinegar. When I last cleaned up here I used cotton bud with some vinegar and just wiped around this area. And we'll do the same thing. That one's alright, look. That contact there looks brand new. I'll give it a clean anyway. So I get some white vinegar into a cap. Start on this side because this is where, look at that, see that fizzing? Yeah, this is why you do need to neutralise it. Stopped fizzing now, look. So we'll clean that out with some IPA in a sec. Just get some paper towel here and we'll just mop up the mess we're making around that area. I've never seen a reaction as strong as that actually with the vinegar. It just goes to show how much alkaline was on that, but that looks new now, look. So I will just do the same thing with the other contacts here. Yeah, very little, if anything, there. Obviously this is going to be leaking inside here, but I am really not fussed. This thing was free with some air fresheners. The main thing is just try and get some more life out of it. Again, no fizzing there, no surprise, the contacts look good there. And the heavily corroded side here, this may fizz a bit, let's see. Yeah, look. Don't know if you saw that, you could hear it perhaps. Yeah, it's not too bad. Let's try with some batteries again. Look, it's not working again. This is what was happening before. Let's try it with these batteries. Hopefully these might work. Nope, I don't know what's going on here. So we've got 4 screws here. Maybe the wire is damaged, or maybe some of the corrosion has leaked down the wire onto a board or something like that. Now you've got to be careful here and open it like that to leave the mechanism there. So you can see the side there is not affected by the corrosion. Nothing's got down onto the board there, I don't think, looking at that. And if we look at this side here, it's the same thing. So it's really weird actually. It could be that this spring here is depressed from all the fiberglass and stuff that I've been, you know, and wire brush have been rubbing on it. And the final, so let's just try pulling it up a bit like that. Let's just see if that makes a good, yeah, you can see you've got a good springy connection there. But no activity. That could be because we've tripped the sensor. But then I would have expected it to have engaged the motor. So I've got the multimeter on volts DC, and if we just measure across there, can you see that? 2.713 volts. So it's a little bit low, but we have got got this the wrong round. We've got almost 3 volts there, look, 2.7 volts. So I would imagine that should be enough to make this work. Yeah, I think we're going to have to take this to pieces further. So this is video footage for my benefit, because I won't remember to put this back together. I think we'll undo the screws here, and then hopefully this whole plastic piece with all the gears and things will just come off. Will it? Yeah, and we can carefully just sit that somewhere. So yeah, you can see here, look, some corrosion has got inside there, and a little bit on the PCB down there as well. Let's just pull the motor out. It's not too bad in there, but can you see down here? We've got a bit of a funny colour there. It could just be corrosion's got inside the motor. So I think we'll soak, yeah, we'll just have a toothbrush around that with a bit of vinegar. With vinegar being an acid, it won't just neutralise but if it gets in there and it gets onto a part where it's affected by corrosion, it will kind of etch the surface a little bit, and then you might find it works. So say for instance it's affecting the commutators or something. Should we pull that board out? Has it got a crack there, or is that black goo? I think that's just goo, actually. Yeah, let's try and disconnect that board, I think. So in order to get that out, it looks like we've got a clip here, look, on each side. Now the hard bit here is unclipping that and then getting the thing out. It could be quite hard to put back together as well, actually, because you somehow need to lift the board. Let's try and pull this wire. You need to lift the board as you push that clip in. Yeah, I think we've got it stuck there, look. There's nothing to grab onto. Let's see if we can pull it there. What can I grab there? There's none of that to grab. Let's just try pushing that one through. Lift the board. Yeah, these contacts here need to... There we go. So you can see I've just about managed that. So the board is super simple, a little crystal there. Quite where it needs a crystal. Oh, there's an IC there, can you see it? So I'll have a play around with that with a toothbrush and vinegar now. Yeah, I think whatever it is, it's super minor. I don't think there's an actual significant fault with this regards corrosion on the board here, because there's just so little, there's just that little bit there. I honestly don't think that's the issue. But you see it's conductive, this alkaline, so you get the battery alkaline there, it conducts, it can cause issues when it's across some of the connections and things, so maybe that's all it was, it's just that bit there. Traces are fine. We've given the motor a bit of a clean there, although we've not cleaned the inside of it. So I'm just going to reassemble that and give it another try. So as you can see, I've fed the terminal into there, that terminal into there, and then we just need to try and push it down into position at the same time. There we go. Just test the button. Yeah, that's in position, and everything here looks okay. So our motor strangely just seems to sit here, doesn't it? It sits on those plastic clips by the looks of things. It's a bit of a weird design, that. So you can see the meter there. Look, 3 volts. So that is a little bit weird. So I've taken the board out again. I'm just going to clean this with some IPA now, actually. I don't see anything. I mean, you can see there I've used the fiberglass pen on that bit of corrosion. The traces are fine there, there's no issues. We'll just paint over that with a little bit of nail polish in a sec. But just on the off chance there is something conductive got on here, despite the fact it looks pristine, because the contacts here is not where, it's not where it's leaked on the other side. And we'll get some contact cleaner into that button as well. What I could do is connect this up to bench power supply, just feed 3 volts in here, make sure you get the polarity the right way, and then test it this way. Wow, that was seriously painful to repair. Let me just show you. It's working. It's not moving very strongly or very fast. The batteries, even though they're showing 1.5 volts, I think the batteries just haven't got enough oomph in them. What I just did there to get that working at all, because I thought, well, the voltage is alright, but maybe it's about current. Maybe as soon as it tries to draw a bit of current, it's dropping or something like that. So I bent the prong out, as you can see, like that, and then filed the top here, and you can see it's like a shiny metal now. That's what you want. If you've not got shiny metal there, you're not going to get a good connection. Anyway, I do need to buy some new batteries, it would seem, because all these ones that I thought were new, I don't think they are. Look, it's not working again. What? Did I just put the wrong battery in? Let's try that battery. Oh, there you go, looks working now. So after doing those things there, this was working for about 2 months, and then I just came to cut some bushes outside with a saw, and I had the power cable out the window, and I knocked it off. You can see I've had to glue it. So I had to use some super glue. All these pieces here smashed off the hinges on both sides. It was completely shattered to pieces. So yeah, this is a tip from my mate Vince. That's where I first saw it. Baking soda. So you put the super glue, join your pieces up, and then put some extra super glue around all the cracks and gaps and things, and sprinkle bicarb of soda over there, and it solidifies it. You know, it's gone rock hard all around, and it's got some strength there. So believe it or not, I can, you know, I'll show you. I can clip this back on. We'll just spread these a little bit, hook one side on, then the other side on. There we go. So it lives to see another day, and I've pressed the button. There you go. It works. I've had this for about 20 years or something. It's crazy how long I've managed to keep this thing going, despite the super glue and stuff. But that's probably never going to be an issue, because the only person that goes in there is me, and I'm just going to carefully lift it up like that and change the thing. There's no stress on it. It's not heavy or anything. So you know, these pieces of these hinges here aren't putting any, they're not under any stress at all once this is clipped on the front. It just sits there. Anyway, in that same room, actually, I now need to go fix the toilet roll holder. It's been hanging off the wall for the last few years, and it's cheesing me off. So yeah, so trust me, this is not turning into a DIY channel, but anyway, nevertheless, this is the next job. Can you see this here? It's really wonky. That one's not so bad, but it's been kind of mangled down a little bit, and this one's hanging off. So the first thing is you need an Allen key, and I think I put some tape over these because the screws kept falling out. So the first thing I need to do is use an Allen key to get under there. Let's just take the toilet roll off. We really don't need it there just now, and pull that out. You can see, yeah, look at that, that's hanging right down. So if we get the Allen key in here, oh hang on, there's no screw there. Is there one there? There's no screw there either. This is the thing, I think those have fallen out in the past, they've gone. So that's one element. I'll need to see if we can find any screws to replace them. And then we need to somehow now loosen these screws. There we go, it's coming out. And then it should come off, I think. I know what's going to happen, I'm going to lose the screw in a minute, aren't I? See, it'll come off. There we go, it's come off now. So you can see how that works. The screw goes into the hole there a certain distance, which then meets up with the gap there. Anyway, so let's just unscrew that. I'm assuming it's in a raw plug. I'm pretty sure, yeah, I can see the raw plug. But the thing is, it's obviously not supporting it, is it? Now, other than, you know, filling that, re-drilling it and putting it in the raw plug, which it might not support very well if you did that. The other thing you can do, which I am going to do, is wedge in a shim. Now the best thing to use, I was thinking about this, is probably a cocktail stick, because they're really thin, aren't they? They're really, really small, and you could just break it, you could wedge it in and then break it off. You know, it's the circumference of the cement and stuff around this that's the issue. But if we wedge something in there, it's going to push. I could even do it on the outer part of the wall there, if I can just get this out a little bit. Yeah, I can, look. So if we wedge our shim in like that, let's just whack it in a bit. I think that's going to be okay. And we'll cut it off flush with the wall there, like that. And then we'll do the same thing on the top side here, I think. I mean, I could try and wedge another one. Let's do another one here. And again, just put it flush like that. You can see this was drilled before. It had something hanging here before, and it's had some filler. But yeah, the thing is here, now this is going to be a lot more tighter than it was, which should hold it. I can feel it's tighter already though. Wow, that is so much. Look at that, it's rock solid. That is rock solid on there. Let's just check this one. That one's all right, I think. We could perhaps do the shim on that one as well, but I think that's going to be okay. So let's get that one back on. Yeah, that's going to be fine. There you go, so it's a lot tighter that. Yeah, so this side here is just hanging down a little bit, but it's the way it's screwed in. So I think that's fine, that'll do. Anyway, hopefully you found that interesting. Thanks for watching. I'll catch you in the next video.